Hello everyone, in this video we'll be looking at the triangles made from shadows. So let's take a look at this situation here. Suppose we had two objects. The first object is going to be this tall building. Okay, and just to show that this is a building, let me go and draw some windows in here. So we have this tall building. And let's suppose our second object is going to be this stick placed in the ground. Right? And we want to figure out what happens when the sun's light, let's draw the sun, right? The rays from the sun reflect off these objects. Okay? So when the sunlights hit these objects, they're both going to cast a shadow. So let's see, when the sun rays hits the building, right? The sun's rays hits the building is going to cast this shadow right here. Similarly, when the sun's rays hits the branch, hits the stick is also going to cast a shadow. So first of all, what shapes are made using the object, the shadow, and the sun's rays? So those three things form a triangle. So what can we know about these two triangles here? First of all, what's going to be this angle down here in the corner? When we have an object going straight up and an object going straight to the side, what kind of angle is formed here? This is going to be a right angle. Okay. So one unique thing about the sun's rays when it hits an object, the two angles formed down here, right? Notice that the sun's rays are parallel. These two angles are going to be equal, right? For this example, let's say that this angle is going to be 50 degrees. Okay, so how can we figure out the third angle? First of all, how many angles what is the sum of all the angles in the triangle? We know that all the angles in the triangle add up to 180 degrees. Okay, and we know that two of them are 90 degrees plus 50 degrees plus this top angle. Those three have to add up to 180. So what should this missing angle be? Well, I know that 90 plus 50, that's going to be 140 so far, plus a little bit more should bring us to 180. And so that little bit more is going to be 40 degrees. Right? And since the other triangle also has a 90 and 50, this third angle is also going to be 40 degrees. So what do we call these two triangles that have all the same angles and but different sizes? Right, these are called similar triangles. Similar triangles. So knowing that these are similar triangles, this can help us find unique properties from the other one. So let's take a look at this next example here. So in this example, here our object is going to be a tree that casts a 15-foot shadow. And over here we have a person, right? Let's pretend this is me. We can draw a tie on him. Maybe put some glasses. Okay. I'm about 5.5 feet tall, and I cast around a 2.5 feet shadow. Knowing that the sun's rays creates two similar triangles, so we have this similar triangle. The sun ray creates a right triangle with me and my shadow. How can I use this to figure out the height of the tree? I want to figure out the height of the tree. There are a couple of different approaches. The first way we're going to look at is going to be using scale factor. Scale factor. So usually I like to think of scale factor as comparing from one triangle to the other triangle. So here, we know the base, we know the length of each shadow, right? So I'm going to draw this red arrow comparing the bases of these two triangles. And the scale factor would be, what do I need to multiply 2.5 to make it the same length as 15? Or, let's write it out, 2.5 times what scale factor times what number is going to stretch it out to 15. Okay, what's the scale factor going to be? All right, that answer is going to be 6, because 2.5 times 6 is 15. So I know that the base is being stretched out by times 6. The nice thing about scale factor is, if the bottom of the triangle is multiplying by 0.6, I know that the height of the triangle is also being multiplied by times 6. So, what would be the height of the tree? If my height is around 5.5 feet, and I'm stretching it by times 6, what would be the height of that tree? Right? So we're going to do 5.5 times the scale factor, and that's going to be 33 feet. Right? 33. So the height of the tree is 33 feet. Right? Any questions about how we use scale factor to figure that out? All right, let's take a look at our next example. So we're going to work with the same problem, except for we're going to use a different method to solve this. So we still have these two similar triangles, but instead of using scale factor, let's go ahead and use ratios to figure these out. Ratios. So the way I like to think about ratios is, instead of comparing from one object to the other, instead of using that red arrow, ratios is like comparing within the same shape. So we're comparing one side of the triangle to its other side. So for example, the height and base of this triangle, these two numbers create a ratio. So let's see, 5.5 by 2.5, right? What's the ratio of the smaller triangle? Well, 5.5 divided by 2.5 is going to be 2.2. And I know that since these are similar figures, the ratio between the height of the tree and its shadow, these two ratios also must reduce down to 2.2. So the height of the tree, question mark, compared to its shadow, which is 15 feet, this also has to reduce down to 2.2. So what should be the height of the tree so that when I divide it by 15, it maintains the same ratio, it stays similar? I can solve this by canceling out the division. Let's multiply by 15 on both sides. Cancel out. So I know that the height of the tree is going to be 2.2 times 15. And like we said earlier on the other slide, that's going to be 33. So the height of the tree is 33 feet. So whether you use scale factor ratios, knowing that the sun's rays hit at the same angle, we can compare the two similar triangles and find the missing side.